Hello, everyone. My name is Haytham Eid, and I'm going to be presenting our speakers today. So we have two sessions, or two presentations for this session. The first one is about from multi-touch table to 3D world, the evolution of making an accessible digital exhibit. Our presenters are Emily O'Hare, Senior Exhibit Content Developer at Museum of Science, and Ben Wilson, Interactive Media Manager at Museum of Science as well. So let's welcome them and learn about their projects. Thank you so much.
Thank you for making it down from coffee. We appreciate that you came to see us. So I'm Emily, and this is Ben. And today we're going to walk you through some of our own development process, some of the key things that we have taken out of it, and process that hopefully you can also adapt or adopt to your own situation. So during today's presentation, we're going to walk you through, as I said, our process, our development timeline. We're going to give you a final exhibit walkthrough, because this is actually a product that's now been on our floor for a bit now, summary, and then we'll have time for questions at the end. So in starting with process, when Ben and I were brought onto the team, it was early in the development of a new exhibition, and the exhibition topic had sort of been decided. We knew that it was going to be about the intersection of the natural and engineered worlds in the Charles River, which is the river that our museum sits on, and we knew what space it was going into. So really early in conception, sort of big ideas about the exhibition, they were also working on getting funding. And so the rendering that is on the screen right now is an early drawing that was presented to a funder. And right in the center, there is a table, and this was to represent a river. In this exhibition, there were engineering activities, hands-on engineering activities, there were observation activities, and then this was going to be the culminating experience. So we wanted visitors to really take a zoomed-out view on making engineering decisions in a river system and then observing the impacts of those things, economic, social, and environmental impacts. And how it was presented to the funder was, it's a big touch table. I don't know, have any of you ever had something presented and then be told you're going to build it, right? Well, that's sort of where we were when we started in this process. Go ahead, Ben.
So we have a hugely interdisciplinary team that contributes to our design process. This is just a summary of the major roles that set on our exhibit development team and influence the development of this component. I think really the main intersections were between our content developer, Emily, and graphic designers, 3D designers, tech designers, software developers, producers of animation, audio. We have a highly iterative process. We're testing with visitors throughout the process. So we do many, many prototypes and iterations. So we have a researcher who sits on the team and helps us really both facilitate the user testing and consolidates the results into things the team can then discuss and provide some action for next steps and next iterations. And of course, we have a project manager who's tying all of these parts together.
So when we're going through a development, usually idea generation very early on, then we're going to walk you through some of our concept development, prototyping. We do many, many iterations, refining the concept, and then finally production. As far as the development timeline, so in the idea generation stage, this was a little bit coinciding with, as I mentioned, that concept for the whole gallery that was being developed, but we were looking at technology too.
Yeah, and so, we had a sketch that was presented to the funder, and so then we went out and, stole ideas from the field, looking at a lot of things that potentially could inspire us, things that we wanted to do, things we didn't want to do. It was presented as a multi-touch table at first, so all of our thinking was around basically creating a digital simulation of this riverbed that multiple people could interact with. That was consistent throughout the project, and I think as we started thinking about accessibility, it's highly integrated into every component we develop. We're thinking about accessibility from the very beginning. That led to a decision pretty much immediately that we wouldn't just fit this content into a multi-touch table. We would actually take a step back, not talk about the technology at the beginning, and actually just think about this in the sense of what are all the pieces of the simulation, what are all the elements that we're really looking at without having to think about the technology, because that leads to many issues of being boxed into a corner if you're thinking about the technology before you're actually thinking about the content and experience. So we immediately just wipe the slate clean. It is no longer a multi-touch table. We're just talking about engineering on a river.
I will note, one last note, when you're wiping a slate clean like that, we do have to interface with our advancement staff very closely to help talk donors through or talk a funder through some of that shift and change. As Ben said, when we were wiping the slate clean from this concept that when you have a team that's all thinking and told it's a multi-touch table, well, now we needed to get everybody on board that it was the experience we were focusing on, and we were going to build the technology around that. So this was the first paper prototype that I actually hand drew out. This is one section of a river, and you can see the river flows going down. On the opposite side, there's it says swimming is allowed. That's a beach that I put on there. And then at the bottom, there is a square, and that's a parking lot. And next to the parking lot, there are dotted line squares. And then on the right-hand side, you have different land covers that you could put on. So you have dirt or grass or permeable asphalt, regular asphalt, and different kinds of shrubs. And part of getting the team, I think, moved past the technology was getting them on board with this activity. So I actually brought this paper prototype. I just Xeroxed out enough copies for everybody to have it, and they sort of played with it themselves, and we talked about what kind of feedback you'd be getting to get everybody on board with the same concept. From there, these are two whiteboard discussions that we had where we were actually laying out what are all of the potential things that could, or scenarios that could go on this river. In the sort of center left, there's waste disposal, which is one that did end up on the final table. There are ones that are up here that didn't end up on there, so we were trying to lay out something that could happen along a river system. The whole exhibition was focused on the Charles River, but we actually at this point removed the specificity of the river because we wanted visitors to be able to make decisions without feeling like, oh, that's the right answer because that's what is on that river out there. We found we needed to disconnect some of the content so that they could think more holistically about their own decision making. And then we outlined what are the variables that they're going to be thinking about, what are the effects that they're going to be seeing or feedback that they're going to be getting.
So at this point, I think we felt we had a solid enough concept that we were ready to start doing some testing with visitors, really building out some prototypes. One of the first changes that was really, I think, came out of the discussion about the outputs and inputs into the system really solidified our move away from using the classic multi-touch table, specifically for the input and accessibility standpoint. We were already thinking about using tactile pieces that would actually be the inputs to the system, rather than having gestures or touching a specific region in a digital context, specifically if we're trying to make this accessible for people who can't see the screen particularly well, then having a tactile cue so we have parity of input for everybody who's using the system if you can't see it. Our first prototype was very low fidelity, but rather than starting with paper, we actually did build out this as a digital prototype from the very beginning. We built an event system, which was essentially just taking keyboard input, and that allowed the facilitator, which was mostly Emily during the testing, just to act as the computer who was recognizing when a visitor was actually placing a piece, and you can see on here, there's central to the image, an open spot for the pipes, and Emily will talk about this in a second, but when a piece was put in there, she just basically hit the key that corresponded with that piece, and that allowed us to iterate without actually having to change the state management and a lot of the other things in the application that we built. We offloaded all the decision-making and state management to the person, but focusing on just the outputs to the system for prototyping.
One of the important things at this stage was we didn't know, well, we have found from past prototyping that visitors have trouble with maps often, like what's the scale, where am I? We wanted to make sure that a top-down view was actually understandable, so that was an initial goal of this. And then also our initial sort of wild dream was that we would do this whole interaction and not have text. We wanted the whole world to be sort of look like a real world that you were walking around, and you could observe observe the effects of your engineering decisions. From this prototyping, we found that visitors just weren't noticing everything. Catching their eye and having them understand an animation that was happening fairly quickly so that they knew that their input did something, they needed that sort of long-term feedback. So we decided to add text after this prototype. The next version of the prototype, we expanded it out. We had 3 sections of the river, 3 different scenarios that you could do along the space, and we were playing with having multi-sided interaction. So in the picture that's on the screen right now, this was a longer table, still had the river scene, but there are two scenarios on one side, and then on the other side was a third, where there's a long parking lot in the center there. And this actually got really messy in that visitors couldn't quite tell what feedback belonged to them. So unlike a flat digital interaction where you're choosing something and usually it expands from that, we were having it within this whole system. And so we really needed to constrain it, and having text going opposite directions didn't work for our visitors. Another thing from this round of prototyping was it was a system. We thought it would be really cool to have the whole system work at like a real river. So when you did something upstream, it would do things downstream. Visitors had no concept that what they were seeing in front of them, well, I triggered all of that, right? Even though there's this green, it's a cyanobacteria bloom flowing down the river. So this bright green stuff, we thought that would be obvious to come right in front of your face, and they never trailed it back to find where it was upstream. So there's still some feedback in the final version that happens and you see it, but it never affects your feedback, the text feedback and the specific animation to your version. We also did the most iteration at this phase. This was sort of our last 2D phase, and we knew once we moved into a 3D tactile space, we were really locking ourselves into layout, to those kinds of, to even like the time invested in creating it and making changes. So we wanted to do that. And this was also the phase that really started to spark conversation. So when we were going through the effects of the scenarios and of the decisions visitors were making, we made a very intentional decision as a team to not have correct answers, which I alluded to before. And this is something that I think felt like a stretch for some folks. It's scary to tell a visitor, like to not be able to have that huzzah moment. But we found that in this version, it was really sparking conversations about trade-offs and about pros and cons of engineering decisions and like real-world effects. So we really pushed to make people a little bit uncomfortable, and that pushed them into that conversation realm.
So after doing a number of iterations on some of our scenarios in 2D, again, we really wanted to maximize the number of builds that we actually did at that point, because it's a lot cheaper just to change the graphics, the animations, everything in 2D. We controlled everything in that world digitally at that point. But again, going back to some of our main goals with accessibility, we really wanted this to be a tactile experience across the board. So we, from this point, felt confident enough that we would actually build out huge parts of this environment three-dimensionally in a tactile way, and then layer the content on digitally using projection mapping and audio feedback associated with it. So this was our first pass at really figuring out how the interaction with the projection mapping, the physical build, and the audio all came together in a limited sense with the scenarios that we had already iterated significantly enough that we felt like feature-wise they were pretty much locked in, and this was just refinement to the actual full final experience. Also in this part, we really were also focusing on what was the projection technology that was going to work out best for this. In the end, this is going to be a really large table, 25 feet long, with 5 scenarios at this point. And that means we're likely going to have 4 to 5 projectors across the whole table to cover it. And that really impacts the readability of every single piece of text on the table. The representation of every single thing we layer digitally needs a minimum pixel per inch count. And we did a lot of just playing with the proximity of the projectors, the throw, the lenses, and trying to keep the projectors from not costing us $50,000 and things along those lines. So, you know, I think we alighted on some compromises, but we found what really worked font and projection-wise in order to get it readable. And that was only something we could manage by seeing how it really laid out on the physical environment. We did some rough estimates early on in the process, but until we had a really modeled table that was to scale, we couldn't make those determinations.
Also at this stage, I'll mention that the earlier prototyping we did mostly with just visitors who were walking through the door. We are fortunate, since we're in an institution that has quite a few people coming in daily, we're able to pull from them to help us out. And at this point, once we had a 3D version, we knew that we wanted to specifically get feedback from people who had low vision or were blind. And so we were able to bring them in and get feedback on both the audio feedback, or the audio, well, yes, we got feedback from them on the audio feedback we were giving them based on their decisions, as well as on tactile surfaces. So this was where we discovered, even though the roofs of the houses were peaked, they needed to feel like shingles. That really cued visitors into that. Having the landscape feel different from the river. So in this case, the river portion, it was Sintra at this point. So it was sort of a cool plastic, and that indicated water enough at that time. So that was the kind of feedback that we were trying to get. We also, the sound effects that we were adding for sort of general visitors who were coming through helped cue them in, and in this particular scenario where you're hooking up the pipes, at one point the toilet backs up, and so it's like glug, glug, glug. That was really cool and cued those visitors in, but some of the extra sound effects, visitors who were blind, I mean, they didn't have anything to associate it with. They didn't know exactly what was happening, so we made sure to really hone in any noises that they were associated with a particular action, and that there was no superfluous noises. And then we moved on to production. So we had this, as Ben said, a 25-foot long table. We worked with a local scenic builder to make this table for us and build it out. And while we were doing this, Ben's team was working on as much animation as was possible without actually having the physical thing you could map to. So a lot of water, how's the water moving? How are the people walking around in the landscape? Those kinds of things. And then once it was installed, then we did the actual mapping of the river scene. So now we're going to do a walkthrough of our exhibit as it's installed. It ended up in sort of a nook in the exhibition space rather than in the center, which ended up helping us out because of lighting. So when you walk into the space, you have an orientation label that gives you the 5 different scenarios. Also in the final table, we ended up adding these legs. So you can see it's this flat system against the back wall, and then the legs that come down help to really define, again, those 5 different scenarios so that visitors are clear about what's your station where you're working at. And then above, you'll see these little cloud bits. That fabric came into hiding some of the technology. We're going to look down now, and you can see there are 5 different scenarios. The head of the river is on the left-hand side, and then it flows to the right. And each scenario, we have one about hydroelectric dams. The second scenario is about agriculture and pesticide use and management. The third scenario is about adding fish ladders to a dam. The fourth one is that first one that I did with the team, which was the land use, and the effects on wildlife around that. And then the last one is the pipe scenario, where you're hooking up pipes. In these, it's hard to see in this photo, but each section, the piece is a different shape. Our designer made sure that the shapes don't fit into one another. So the circle doesn't fit in any other piece, the triangle doesn't fit in any other piece, so that we wanted the pieces to be able to be moved and to be able to be compared. We found comparing was a big thing for visitors. They needed to be able to really compare the pieces. So we wanted them to be able to not mess them up either. So you can really find the home station.
So this is just a cross-section of basically the layout for between the projection, the audio, and the table itself. There's actually 5 overhead digital projectors pointing down. They were LED and laser-based. And then the sound domes, which you can see are just sort of semicircle, are for doing some degree of focusing sound over each station. It's worth noting that the audio comes in a couple of different formats, sound effects that are associated with each output that on the table. So there is some meaningful feedback that's in audio, and then there's also a button that will read aloud the current state of everything, so it gives you basically a mirror for the text callouts at that point, and that audio is station by station. You can hear it roughly from other ones, but it's not disruptive. For the actual interface, these are tactile pieces. We started some testing using RFID for being able to trigger it, but in consultation with our tech designers and our exhibit maintenance team, we actually moved to Hall effect switches, basically senses a magnetic field. So there's just small series of magnets inlaid in each piece that creates a switch, and just the number and position of magnets determines what piece it is. That made it really easy to maintain going forward, because if something breaks, you just stick another magnet in place and you don't have to worry about programming RFID readers or anything along those lines. And the computer just basically sees keyboard input from an Arduino, so that really made the testing and input structure very, very simple for us.
The pieces themselves, we had 3D printed. We originally tried just using the 3D prints, and they could not withstand our visitors. So we now take the 3D prints and we actually cast them in-house, so that way we can make multiple versions in a more affordable way. These pieces are pretty substantial in the sense of how much plastic you're printing. Each one has a handle so that you can pick it up easily, and then with a tactile number so you know which piece it is, and Braille next to it. And the back of each piece, we found that was a natural place that visitors were looking for if they wanted a little bit more definition of what each piece was doing. And now finally, we're going to show you, this is a video of that agriculture scenario. So when you put a piece in this particular scenario, a plane flies over spraying pesticide. Then you have a cloud come over when it rains, and you see the pesticide washing into the river, and then it affects your fish population. You're also getting feedback about water quality, as well as how many crops are being produced. So this was the range of feedback that we wanted to have visitors really think about. So you're making this decision, and then you're getting feedback. So drinking water was sort of a social impact, the fish were your ecological impact, and then the crops themselves are the impact of maybe a person. And we found some visitors were actually identifying themselves and saying, oh, if I'm a farmer, well, I want this particular decision, and well, heck with fish, I don't care about fish. But other people were getting very passionate and, sort of taking on their own roles in this scenario. And then we also have the no piece version triggers as well. So each scenario has 3 different pieces. We did this for consistency's sake down the river, but we also found, again, as I said, visitors were trying to compare them, and 3 seemed like a good number where you could get some diverse feedback without being overwhelmed by the choice either. Does it work? I almost forgot. We're in the middle of remedial evaluation. We've had accessibility advisors come in, and we are going to tweak some of the descriptive audio that we have, setting up each scenario. So in addition to the sound dome above, we have an audio phone that gives you sort of a layout description at each station. So we're making some tweaks on that. Primarily, we're finding that visitors are using each station as a group. Some are splitting up and doing multiple at the same time, but often they're traveling sort of down the river together. 70% of visitors are mentioning that they're seeing effects on both the natural and engineered worlds. We feel successful about that. And then 80% are specifically mentioning trade-offs or pros and cons as things that they're noticing. We do have still a percentage of people who say that they're sort of frustrated they didn't get the right answer. So it's something that we're acknowledging. It was sort of an original goal, so we still feel good about where that ended up.
So in summary, in a lot of ways, we, throughout the project, saw a lot of confirmation for what were really kind of our guiding principles throughout the development, which is somewhat rare in a project in the sense that through the iteration, through the concept development, you know, a lot of things will actually change. Challenges will be, assumptions will be challenged, but in this phase, some of our main decisions actually were extremely fruitful and led to a very successful exhibit. Interface side, you know, I can't emphasize enough. I mean, it's kind of one of the main ways that we approach everything, but we do not let the technology dictate what the experience is going to be, the other way around. So no matter what, we don't want to fill a screen with content. We want to think about the content and then apply the technology to that. And that also allows us for a lot of flexibility and really solid evolution of any concept that we have. So we can iterate concept before painting ourselves into a corner with technology.
When prototyping, we do try and be fairly fast about it, but really recognizing what kind of feedback we want at each stage. So as Ben said, we knew in the 2D version we needed to get as much iteration as we could quickly, but we did hold off on inviting in visitors who were blind until we had something tactile for them to give us feedback on. So that relates down to our accessible engagement, including the multimodal content, but making sure to test for the audiences that it's meant to engage, and also testing it across audiences, since it's all going to be there in the end. And finally, getting goal-oriented feedback. That was referring to especially the sound effects, where we had to make sure that our goal was to have visitors notice the different effects of their decisions. And so we needed to make sure that the feedback we were giving to every group who was using the table was getting that specific feedback, and sort of avoiding the noise.
And I just, one parting thought on it is that we really, through the development of this and the positive feedback we've had from visitors, really looking at a lot of the things that we learned from this as impacting our overall strategy for how we're developing digital exhibitry across our institution. Really helping us continue in the evolution that we've started with, where we're not really just having standard kiosks like have been in so many of our exhibits in the past and across many exhibits in the field, really moving to this tight integration of the digital and the tactile. So that's what science centers are great at, is these hands-on, multi-user group experiences, and we really want the digital to be a layer on that and an accent and an integral part to it, rather than just being, you have this great tactile thing and then a deep label or a glorified web page sitting in a touchscreen next to it. So really integrating with projection mapping and audio and other unique inputs and outputs into the tactile and physical exhibitry.
2 minutes or no, anytime?
If you want to take a couple questions.
Any questions? Yeah.
So I really appreciate your honesty in talking about this. And so a couple questions are, what was the time frame from when you first said, or, oh, we want a 3D table, multi-touch table, we have a donor, and then also this sounds like a lot of work for both your groups on testing. Was this like full-time jobs for everyone for weeks or months, or were you trying to work this into your regular jobs? And also then the support of it, is it fairly easy? Well, it's not live yet, right?
It is live.
Yeah,
Yep.
it is live. So
Yep.
is it easy to support with the sound domes and the projectors? So, anyway, I don't want to put you on the spot, but it would be helpful to hear a little more about it.
So the question was a little bit more about our timeline, workload, and maintenance of it. So timeline, it was about 2.5 years from concept sort of funding to implementation, or to opening. Workload, we can do workload maybe.
Well, I was just
Go
going to say on timeline, but that 2.5 years was the gallery as a whole.
Yeah,
It wasn't just
that
this
was
component.
workload.
I mean, so yeah, to workload, we're balancing multiple components, many large design components in the gallery.
Yeah, so it was about a 3,500 square foot exhibition as a whole. So this was just one component within that exhibition. We could talk probably offline more specifics. And then maintenance, I think the biggest issue originally was those pieces, because they have the magnets embedded in them and they're sandwiched and we have the labels, they were falling apart and visitors were breaking, well, when we tried the 3D printed versions, visitors were breaking those handles off. They just get dropped a whole lot. So I think that was actually our biggest. We haven't had really like tech issues in that way.
Yeah, the projectors and sound domes, they're working great. Haven't really been any maintenance issues. There's 5 projectors and alignment's critical for it, so we actually built a fairly easy system digitally to tweak the alignment between projectors and blend it just with some keystrokes. So there was construction going on above this, so we had to realign a few times because there were jackhammering and removing things. That was actually surprisingly painless, and that was the only real part of maintenance was other impacts to the facilities.